Okay, earlier we talked about when you use the SHL shift. When you shift left n bit, that's equivalent to you multiply the operand by 2 to the nth power. So when you use the SHR, when you shift right n bit, that means you divide the operand by 2 to the nth power. So the next question is, it's possible we can using the SHL to multiply any value or use the SHR to divide any value instead of only 2 to the nth power? The answer is this one, yes, but division, not. So actually, when you do the division, you only can divide either by 2, shift right to 1 bit. Divide by 16, shift to the right for 4 bit. Because when we do the divide, they only can just divide and divide. But when you do the multiplication, that will be kind of a little different. Even we say shift to the left, if we want to have my operand become 4 times bigger, so then I shift to the left for 2 bits, right? So then I want my operand become 32 times the operand. So I can do 2 to the 5th power. I shift to the left for 5 bits, become 32 times, right? Can I make my value become 102 or 95? I can have any number to multiply using the SHL. The answer is yes. Why? Because multiplication, actually we have the other thing is, even I try to do, for example, I say I want my EAX become 36 times bigger. Right, I know 36 is not 2 to the something's power. But actually for any number, no matter you are a positive number or a negative number, they all can break into binary number, right? So this one just like 36 equal to 32 plus 36. Let me do here. 36, do you agree? 36 equal to 32 plus 4. Right. So that's why when I have the EAX, I want to times 36. I can consider I just break this 36, become another 2 to the nth powers combined. So you can see here, 36 is 32 plus 4. Wonderful. 32 is 2 to the 5th power. So then 4 is 2 to the 2th power. So on the other hand, if I want to find the EAX times 36 bigger, I just need to do what? I can do the EAX, shift to the left for 5 bits. So after I get the value, then I shift EAX to the left for the 2 bits. So then I add them together. Now I get the EAX times 36. So that's how we will do that. So actually for the binary multiplication, no matter what value you want to multiply, we all can break down into multiple SHL instruction. So for example, like this one, how should I do the 36? So what should I do is I just need to have my EAX. I have the EAX for the original value, right? Then the first time I need to do shift to the left for 5 times. So I can have the EAX value I move to EBX. So then I use this the EAX to shift to the left. So that's why this one is like the original value times 32. So then afterward, I have the EBX. I just need to use the EBX to shift to the left for 2 times. So on the other hand, that means the EBX contain the original EAX value times 4. Then I add them together. So did I at the end get EAX times 36 bigger? Remember, anytime you can post the video. If you are not sure, you still have a question, write it down. So then you can either post in the discussion or we can talk about that during our Zoom meeting. Okay, so if you are okay with that, so I want you to try the next example by yourself. So now this one is, if I want to multiply AX by 26 bigger, how can you only use the SHR instruction and additional instruction to get the result? So the hint is, can you break down 26, become all the 2 to the nth power add together? Right, so we know 26, the closest one is 16. So 16 is 2 to the 4th power. So then 26 minus 16, I still have a 10 I need to fill up, right? So the 10 equal to 2 plus 8. So on the other hand, this one actually means, so 26 equal to 2 to the 4th power plus 2 to the 3rd power, 2 to the 1st power. So can you finish the assembling code? So pause the video, complete your assembling code, then you can check the answer again. So that's the result. So right, so we just say, for example, our AX, the original value, can give them any value. So at the end, we will do the 26 times this value. So that's why here, remember, we need to save the original value, because all the time SHL, they will have the destination value changed. So that's why we move AX to the DX. So we do the first one. The DX, we will shift to the left for 4 bits. So that means we finish 2 to the 4th power. So then you can either use the DX, then you continue to use other registers. But on the other hand, actually, since you want to, if you want to use the DX to redo that, right, we can push to the stack, right? So then continue, after I push the DX, this one is the original value times 2 to the 4th power. So I just have the AX is the original value, I move to the DX. So then we do the next one. So we do the shift to the L for the 3. So then of course we have originally our AX. So this one you can just shift to the 1 time. So then after we done this one, so we add DX for the 2 to the 3rd power. So then you pop, since DX already finished their job, so we pop the first time for the 2 to the 4th power. So then we got the final value. The AX will become 26 bigger. And actually you can name any integer. We can do the multiplication to fill that up.